Welcome to Module 4, Network Data Transfer Methods. In Section 1, we'll begin with an overview of the different types of data communications, followed by an introduction to broadcast and collision domains. We'll explore how physical and IP addresses uniquely identify devices on a network and facilitate the smooth routing of data packets to their intended destinations. And we'll look at how the Address Resolution Protocol ties the physical and IP addresses together. Lastly, we'll review broadband and baseband technologies and the evolution and overview of the Ethernet. By the end of this lesson, you will have a solid foundation in the principles of network data communication, ready to apply your learning to real-world networking challenges or further academic study. Whether you're a budding network professional or an IT enthusiast, this course will pave the way for your future endeavors in the field. Let's begin with a look at how computers communicate. Imagine we have a network of 6 computers. Each wants to communicate with the group or members of the group. In computer networking, there are 4 types of communication that can occur. Click each type to learn more. Anne wants to send a confidential document to Barack. The document is sent directly to Barack, ensuring no other computers on the network receive it. This is like a private conversation where Anne speaks only to Barack. In this instance, Anne uses unicast communication to send this document. Unicast is a one-to-one type of network communication where a single sender transmits data to a single receiver. This is the most common form of data transmission on the internet and is typically used for most web traffic, like loading a website or sending an email. Select the next option. Now, Anne has a video that needs to be sent to Caroline and Devin, who are part of a special project group. Anne sends the video simultaneously to both, but interestingly, Barack, Eaton, for Fatima don't receive the video. This type of communication is called multicast communication. Multicast refers to a one-to-many communication method where data transmission is addressed to a group of destination computers simultaneously. Multicast is efficient for streaming media, like live video or audio, where multiple users might receive the same content at the same time. Select the next option. Anne sends a request for the latest software update. Computers Eaton and Fatima both have the update, but the network chooses the computer that can respond the fastest, which in this case is Eaton. This is an example of Anycast communication, which ensures that Anne receives the update quickly, even though it could have been served by multiple computers. Anycast is a one-to-nearest form of communication where data is sent from a single sender to the nearest or best located receiver from a group of potential receivers. This is often used in content delivery networks where the same data is stored in multiple geographical locations, and the goal is to deliver data quickly and with the least latency. Select the next option. Fatima sends an alert to all computers on the network about a scheduled maintenance shutdown. In this instance, a broadcast communication will be used so the alert is received by all computers simultaneously. This is like a public announcement over a loudspeaker that everyone in the vicinity can hear. Broadcast communication is a one-to-all communication model where data is transmitted from a single sender to all possible receivers within the network segment or broadcast domain. This is common in local area networks where messages like Address Resolution Protocol requests are sent to all connected devices. Click Next to continue. In networking, a domain is a network that has different network devices connected to it. When computers are communicating with each other, it is helpful to clearly understand how the data is managed across the network. There are 2 commonly known domains: collision and broadcast. Click each to learn more. A collision domain is a network segment where data packets can collide with one another when being sent over a shared medium. In this domain, only one device can speak at a time, and all the other devices need to listen. If 2 devices on the same collision domain try to send data at the same time, a collision occurs. The data packets collide and are either dropped or must be resent, which can lead to network inefficiency. Ethernet networks with a hub or repeater are typical environments where collisions can occur, although the use of switches and full duplex configurations can reduce or eliminate collisions. But what if all the computers need to send data at the same time? This can be accomplished using carrier-sense multiple access with collision detection. This improvement enables devices to detect if there is a device sending data in the collision domain. Using CSM/CD before sending data inside the domain at any point in time, devices will listen to the network media to ensure no one is sending before they can send. In the case of a collision, the device notices and sends a jam frame, waits for a while before sending it again. Select the next option. A broadcast domain is a logical division of a computer network in which all nodes can reach each other by broadcast at the data link layer. A broadcast domain can include several different physical network segments and is bound by routers. All devices in the same broadcast domain will receive broadcasts sent out by any other device in the domain. In this example, computer A is sending a broadcast and the switch will forward it to all the ports. Every connected switch will get a copy of the broadcast packet. Here, all the switches will send the broadcast packet to all ports. But how does the data know how to get to each destined device in a broadcast domain? This is where understanding physical and IP addressing is important. Let's take a look. Click Next to continue. Remember the OSI reference model that we discussed in Module 2. We mentioned that computer devices in a network usually have an address for the data link layer and one for the network layer. But why does a computer need two addresses for delivering data? Let's take a look. In a network, each device is assigned a physical address, commonly known as a media access control or MAC address, on each network interface it has. For example, if a laptop computer is equipped with both wired and wireless network capability, each interface will have a unique MAC address. These addresses are commonly represented with a set of 12 numbers and letters. They are unique and permanent and are not expected to change. MAC addresses operate at Layer 2, the data link layer of the OSI model. When a frame is put on the local area network, the MAC address is used to ensure it reaches the correct destination within the broadcast domain. Similar to a physical address, the IP address is also a unique identifier for a device on the internet or within a local network. It's a group of 4 numbers made up of a string of integers separated by periods, for example, 192.0.2.0. IP addresses operate at Layer 3, network layer of the OSI model, and are used to identify devices across different networks. So how is a physical address converted to an IP address? This conversion is accomplished using the Address Resolution Protocol or ARP process. ARP requests are broadcasted to all devices within the domain, and the device with the matching IP address responds with its MAC address. Let's say that host A wants to communicate with host B. Host A knows the IP address of host B, but it doesn't know the host B's MAC address. In order to find out the MAC address of host B, host A sends an ARP request listing the host B's IP address as the destination IP address and the MAC address of the Ethernet broadcast. The switch will forward the frame out to all interfaces except the incoming interface. Each device on the segment will receive the packet, but because the destination IP address is host B's IP address, only host B will reply with the ARP reply packet listing its MAC address. Host A now has enough information to send the traffic to host B. All operating systems maintain ARP caches that are checked before sending an ARP request message, and each time a host needs to send a packet to another host on the local area network, it will first check its ARP cache for the correct IP address and the matching MAC address. Broadband and baseband are 2 types of data transmission technologies used to send and receive data over a network. Click each to learn more.